Okay, so this is another recording on what I predicted will come out in paper 2. Now, it is one of the learning outcomes under hydroxy compounds, which is alcohol. Number 5 here, you are required to explain the acidity of alcohols compared to water. So that means both alcohols and waters, they are acidic. Okay, they're actually both weak acids. So which one is stronger? Okay, which one is weaker? So here we'll compare, okay, acidity of alcohol, okay, more acidic or less acidic than water. And also we are going to explain why. Okay, so we are focused on these 2 points. Now if we look at the acidic properties of alcohol, it is a weak acid. Okay, weak acid. So once it is dissolved in water, it partially dissociated in the aqueous solution to give us an alkoxide ion. You see, the alcohol donated proton as an acid, so we get an alkoxide ion and also a H plus ion. Okay, or here they write how the H plus is accepted by a water molecule to become hydroxonium, but you can always simplify these to hydrogen ions. So in the equation, you do not have to include water. It's not wrong to include water also, but you can always simplify to this equation. Yeah, they are still the same. Now, since alcohols they are weak acids, so the position of this equilibrium, you can see there is equilibrium because of the reversible arrow. Now, this position of equilibrium lies very much further to the left hand side, okay, because it's a weak acid, so it prefers to stay as a molecule compared to donate proton. So you have low concentration of hydrogen ions in the solution. That's why alcohols are weak acids. Then now let's compare acidity of alcohols, okay, with water. So all alcohols are weaker acid than water. Okay, all alcohols. Now, why are they weaker acid than water? Because all alcohols contains electron donating alkyl groups. So if you cannot remember alkyl groups are alkanes, okay, alkanes with one hydrogen less, like CH3, okay, like methane. You deduct one hydrogen, so it became CH3. So this is an alkyl group, C2H5, okay, C3H7, and then you can go on and on and on. They are all alkyl groups. So all alcohols will have these alkyl groups. Now I have an example here, ethanol, a two carbon alcohols. So the alkyl group is C2H5. C2H5 bonded to the O. So this OH, okay, this OH is the one responsible for donating the proton, and it is bonded to an alkyl group. Now this alkyl group, they are electron donating group. They have positive inductive effect on the oxygen. So meaning they are donating electrons to the oxygen. So making this oxygen has high intensity of electrons. Okay. Then of course, the O is also bonded to the H. So this OH bond became stronger because you have more electrons coming from the left hand side in this case, yeah. So is this intensity of electrons are also enhanced, okay, increased. So this OH bond become very hard to be broken. So this alcohol is not likely to donate the proton. Now, also this O here, the alkoxide ion that is formed from the dissociation, this O has high intensity of electrons, so making this negative charge, okay, very negative. Okay, more negative than without alkyl group. Okay, like in water, right? In water, you have H2O, so there's no alkyl group, there's only H. So this O is more negative than the O in water, which also leads to the instability of this alkoxide ion. If this is very negative, it will always grab, okay, accept a proton from the solution and reform the molecule. So we are going to have lower concentration of hydrogen ion. So compared to water, there's no alkyl group. Okay, so the dissociation is actually more normal. Okay, nothing unique about it. So all alcohols, because of the alkyl groups having positive inductive effect on the O, making the OH bond stronger, making the alkoxide ions less stable, so they are all more acidic than water. Okay, now you know the reason. I'm going to show you a few questions that I created. Now, why did I create mock question? Because this is new in the syllabus. There's no any precedent questions from past year papers. So the first one that I created is a more straightforward question. They will ask you to explain why alcohols are weaker acids than water. Or they can change it to any alcohol. They can say explain why ethanol is a weaker acid than water. So, okay, if it is a 2 marks question, this is how you answer. Ethanol is a weaker acid than water due to the positive inductive effect of the alkyl group. Okay, be more specific. If question asks for ethanol, you can say C2H5 group. Second mark will be OH bond is strengthened. Okay, because of the positive inductive effect of the alkyl group, the OH bond is strengthened. Okay, so this is how you answer 2 marks question if you are asked to explain why alcohols are weaker than water. Now, let's look at mock question 2. You can be asked to describe and explain how the acidity of ethanol compared to that of water. So again, they can change this ethanol to any alcohol, and you still answer the question by using the same point. Okay, whatever alcohol that you are given, you always say that it is less acidic than water to get the first mark, because you are asked to describe, okay, the acidity compared to water. So you should always tell which one is less acidic first. Okay, so alcohol is less acidic. Now, second mark will be the explanation. Okay, can you see that this second mark answer, due to the positive inductive effect of the C2H5 group and OH bond is strengthened. I actually copied from the answer of mock question 1. Okay, now I combine these two to get the second mark for mock question 2. It, I, and I predicted it to be a 2 marks question. So the first one is to describe, second one, explain. Later, move on to mock question 3. Okay, now let's look at mock question 3. Mock question 3 is something that I predicted might come out, but it is more difficult than mock question 1 and 2. This one is less likely to come out because I want you to compare the relative acidities of butan 1-ol to methyl-propan 2-ol and water. Now, butan 1-ol look like this: CH3, CH2, CH2, CH2OH. It's an unbranched alcohol, 4-carbon alcohol. 2-methyl-propan 2-ol is also, okay, a 4-carbon alcohol. Sorry for typo. Let me cancel its E. CH3, CH, CH3 again, CH3, then OH. So 4-carbon, right? But this time, the OH is bonded to a C that has 3 alkyl groups. This one, okay, is a primary alcohol. This is a tertiary alcohol. So how do we compare? Okay, before we answer this, I'll go through an explanation. Now, look at the trend first. Primary alcohol, secondary alcohol, and tertiary alcohol. Okay, the most acidic one will be primary alcohol, followed by secondary alcohol, and tertiary alcohol is the least acidic. So remember this trend. Okay, now I'll explain to you why. Because primary alcohol has only one alkyl group. Secondary alcohol, okay, two alkyl groups, and tertiary alcohol, three alkyl groups. The more alkyl groups you have, okay, in an alcohol, okay, that is bonded to the O, yeah, uh, bonded to the carbon that is bonded to the O. More alkyl groups, more stronger the positive inductive effect. Okay, more unstable is the alkoxide ion that is formed. Now, again, unstable means more likely to grab, accept a proton in the solution and reform the molecule. Then you have less hydrogen ions in the solution, less acidic. Okay, so primary alcohol is the strongest acid. Tertiary alcohol is the weakest acid. For the stability of alkoxide ions, primary alkoxide ion is the most stable. Tertiary alkoxide ion is the least stable because the O here is the most negative. So now let's go back to the question, mock question 3. You're supposed to compare the relative acidities of butan 1-ol, 2-methyl-propan-2-ol, and water. So butan 1-ol is a primary alcohol, 2-methyl-propan-2-ol is a tertiary alcohol, and also water. Water is not an alcohol. Now, alcohols are always weaker acid compared to water. So the most acidic here will be water. Okay, just now I explained to you primary alcohol is more acidic than tertiary alcohol. So butan 1-ol will come first in this order, and then the least acidic will be 2-methyl-propan-2-ol. No, we're not done yet because the question says explain your reasoning. See, this is 3 marks question. 1 mark will be given to this correct order. Okay, so second mark will be comparing butan 1-ol and also 2-methyl-propan-2-ol. And butan 1-ol, the positive inductive effect of the C4H9 group strengthen the OH bond. That's why it's in the middle. That's why it is a weaker acid compared to water. And now, why 2-methyl-propan-2-ol is even weaker than butan 1-ol? Okay, because it has more alkyl groups than butan 1-ol. So the OH bond in the 2-methyl-propan-2-ol is stronger than that of butan 1-ol. Okay, 3 marks question. First for the order, second for the explanation of why butan 1-ol is in the middle and why 2-methyl-propan-2-ol is the weakest one. Okay, so that's all for this recording. Okay, I've just explained to you how to explain acidity of alcohols compared to water. And these are the mock questions that I created. So if you have more questions on that one, always post your question in the comments. Okay, thank you and good luck for your exam.